Hello colleagues, and welcome to the second part of our big lesson devoted to the lifecycle of AI systems. In the first part, we covered a huge and critically important journey, from the spark of an idea and answers to strategic questions all the way to a fully built and tested product. We laid the foundation of our governance system, created the first versions of the AI System Passport and the Risk Register, and examined in detail the stages of strategy, planning, development, and testing. Our system has undergone comprehensive verification, received approval at all gates, and now stands at the threshold of the real world. Our task is to discuss how to release this system safely into the production environment and how to manage its long, effective, and responsible life. We will analyze the remaining 4 stages that turn a finished product into a continuously operating, value-generating asset. Let's continue our journey. So, our system has passed comprehensive testing and received formal approval at the previous stage. The responsible and exciting moment arrives: deployment. This stage is dedicated to the safe and controlled transfer of our AI system from the test lab into the real production environment. The key question here is, how do we safely and effectively embed the system into business workflows? Here the lead roles are played by DevOps and MLOps engineers, as well as change management and training specialists. The main activities of this stage are: preparation of the production environment. All required servers, databases, and network components on which the system will run are created and configured. Technical deployment of the model. The model itself and the accompanying code are transferred into this environment. Final configuration of integrations. The AI system is connected live to other enterprise systems. And training of end users. Trainings are conducted, and guides and materials are prepared so that users are ready to work with the new tool. The result of this stage is a fully functioning, user-accessible system and a trained team ready to work with it. At the deployment stage, our function is ensuring flight safety. We act as the final controller before launch. First, we conduct a final assessment of deployment risks. We open our risk register and focus on threats specific to the deployment process itself. For example, what if a failure occurs during data migration? What if real-world load turns out higher than estimated? We verify that response plans exist for these risks. Second, we validate the readiness of monitoring and incident response systems. We don't configure the dashboards, but we verify that they are configured and functioning exactly as planned back at the planning stage. Are there alerts? Does the support team know what to do when they receive them? We also check the presence and operability of the emergency shutdown mechanism, kill switch, and confirm the assignment of a responsible operator for the controlled launch period. The ethical aspect here manifests in change management and communication. Our task is to ensure that users are not simply presented with a fait accompli. We verify that the communication plan is clear and transparent. Users must be told honestly not only about the system's benefits but also about its known limitations. Clear channels must be provided for feedback and for appeal if a user disagrees with the system's decision. Finally, we update the AI System Passport with final details. We do not create a new version, we augment the one approved at the previous stage. We enter the exact go-live date and the chosen deployment strategy. We add links to the incident response plan and user training materials, and we record the final go-live decision. There is no formal gate at this stage, since the launch decision has already been taken. Instead, we have a final go-live readiness checklist. This checklist is in essence, our criteria for transition to full production operations. The production environment is ready, tested, and protected. Monitoring and alerting systems are working and have been verified. Key users have completed training and have the necessary materials. The support and incident response team is ready and knows its duties, as confirmed by the presence of an incident response plan. Only when every item in this checklist is ticked can the system be officially handed over to operations. It's long, and we hope productive life in the real world begins. The system is launched, and users have started working with it. Can we exhale and consider the project complete? Absolutely not. For AI systems, launch is not the end but only the beginning of their real life. We enter the longest stage of the life cycle, operations and monitoring. This is a continuous, cyclical process that lasts as long as the system provides value. The key question at this stage, is the system working as we expected, and does it remain safe and fair in a changing world? Here, primary responsibility lies with operations teams, support, and data specialists. The main activities of this stage are performance monitoring. Key technical and business KPIs are continuously tracked. Model-specific monitoring. This is what distinguishes AI from traditional software. We monitor phenomena such as data drift, when inputs begin to differ from those on which the model was trained, and concept drift, when the underlying relationships in the real world change. In addition, at this stage the data quality metrics defined earlier, completeness, consistency, timeliness, and others, become operational indicators with set threshold values. Breaches must automatically trigger escalation and response processes. User support. Assistance to users is provided, and their feedback, complaints, and suggestions are collected. And technical maintenance. Regular updates are carried out, bugs are fixed, and the system is optimized. The result of this stage is a stable, continuously value-producing system and a continuous flow of telemetry about its state. At this stage, our task is to ensure that the system not only works but remains under control. We move from project management to continuous oversight. First, we organize and conduct periodic risk reviews. Together with our cross-functional risk team, we audit the risk register. Have new threats appeared? Has the likelihood or impact of existing ones changed? All changes are immediately entered into the register. Second, we track the monitoring of specific governance metrics. The technical team configures the dashboards. Our task is to ensure they display, in addition to technical indicators, our governance indicators, fairness metrics, has the model started discriminating against certain groups over time, and the frequency and severity of incidents, how often problems arise and how critical they are. The ethical aspect here manifests in incident management and feedback analysis. When an incident occurs, say, the system produces an obviously incorrect or offensive result, we must ensure the team does more than fix a bug. We initiate a post-mortem, an analysis of the incident's causes. We also analyze user complaints for hidden ethical issues. At the same time, we ensure that the incident response plan not only exists but is regularly tested through drills, and that its effectiveness is subject to periodic audit. And finally, we keep the AI system passport up to date, turning it into a living document. We ensure that it is regularly updated with links to incident reports, postmortems, results of quarterly risk reviews, and information about identified issues. This stage also has no formal gate in the classical sense, as it is continuous. As we see on the slide, the transition to the next stage, evolution, is triggered by specific signals. The first and most frequent trigger is model degradation as shown by monitoring data. Our dashboards may indicate that system performance has declined or that it has become unfair. This can be caused by the data drift and concept drift we discussed. The second important trigger is the need for improvements based on feedback analysis. Users may request new useful functionality, or their complaints may point to usability problems or result in accuracy. And finally, the third, strategic trigger is the emergence of new business requirements. The company may enter a new market or change its strategy, and to support these changes our AI system will need to be adapted and enhanced. Any of these signals becomes grounds to start a new change cycle, returning us to earlier stages, as we discussed at the very beginning. We will examine this process at the next stage. We already said in the first part that AI systems are not static. They live in a dynamic world where data and business requirements constantly change. Therefore, after deployment the system does not freeze but enters a continuous cycle of evolution and optimization. This stage consists of a series of iterations and answers the key question: how do we improve the system while preserving its safety and reliability? The main activities here are performed by the product and technical teams and include additional training or retraining of the model, adding new functionality, performance optimization, improving the user experience. The result of each iteration is a new, improved version of the system. However, any change, even the most minor, carries potential risks. Our main task at the evolution stage is to ensure that the improvement process is controlled and safe, implementing the principle of governance by design for every change. We introduce and enforce a formalized change management process. First, we organize an impact assessment for each change. Before changing anything, we must get answers to the questions: how will these changes affect existing risks? Will they create new ones? Will training the model on new data introduce new biases? These questions must be part of the impact assessment. We classify changes by risk level. Not all changes are equal. Low-risk changes, such as interface tweaks, may follow a simplified process. Medium-risk changes, such as full model retraining, require more thorough analysis and testing. High-risk changes, such as a model architecture swap, in effect launch a new lifecycle version, requiring a repeat pass through key checkpoints and gates. Third, we oversee regression testing. We must ensure that the new change has not broken what previously worked well. And finally, we enforce strict versioning and documentation. Every new version of the model and system must be recorded. The AI System Passport is updated. It gains a change management section that briefly describes what changed and provides a link to the impact assessment. The risk register is updated as well. The evolution process we just discussed can indeed be very long, consisting of many cycles. But, as we see on the slide, it is not endless. Sooner or later, a moment arrives when further development of the system becomes impractical, and a decision is made to transition to the final stage. This decision is not spontaneous, it is based on several key criteria. The first and most obvious criterion is economic impracticality. A point is reached when the costs of maintenance, model retraining, and new feature delivery begin to exceed the value the system brings to the business. Put simply, we spend more on it than we get back. The second criterion is technological obsolescence. The world of artificial intelligence is advancing rapidly. A fundamentally new algorithm, cloud service, or off-the-shelf solution may appear that solves our task an order of magnitude more efficiently, cheaply, or accurately. And the third, no less important criterion is strategic irrelevance. Business does not stand still. The process our AI system automated may be abolished, radically changed, or the company may simply exit that line of activity. The system may remain technically excellent, but the task it solved has ceased to exist. When one or more of these criteria are met, a considered managerial decision is taken. Further evolution is impractical. But there is also a fourth, special scenario. This is when the decision to decommission the system is not ours to make, it is made for us. This is a direct order from a regulator prohibiting the use of the AI system. This happens when the entire governance system we build throughout the lifecycle, from strategy to monitoring, suffers a critical failure. When the risks we were supposed to identify, assess, and mitigate materialize in the real world and cause harm. What might this be? Systemic discrimination that was not detected at testing. A gross violation of personal data protection laws. An inability to explain how the system made a life-affecting decision for a person. In such a case, the regulator does not ask, it orders, and further use of the system becomes simply unlawful. This is no longer a business decision, it is a consequence. A consequence of inaction or wrong actions. And it is the clearest illustration of why everything we discuss in this course has absolutely real, and sometimes critical, significance for business. It is precisely then, when the decision to end operation has been made, voluntarily or as in this case, forcibly, that we move to the final stage of the life cycle. Nothing is eternal, as we mentioned at the beginning. Even the most successful product will one day complete its life cycle. A moment arrives when the system becomes obsolete, is replaced by a more advanced solution, or the business need for it disappears. Then we enter the final, but no less important stage, decommissioning. This stage is often underestimated, but mistakes here can lead to legal trouble. The key question of this stage: how do we safely and properly end the system's operation? The decommissioning process is a carefully planned operation. The main activities include data retention planning. We determine which data must be retained in an archive and which must be safely deleted. Migration planning. If the system is being replaced by a new one, a plan is developed for a smooth user transition. Communication with users. Everyone is notified in advance about the upcoming shutdown. And the technical shutdown itself, physical or logical shutdown of the system's servers and interfaces. The result of this stage is not only a stopped system but complete order in the data, processes, and knowledge associated with it. At this final stage, our task is to ensure legal cleanliness and preserve accumulated experience. We act as archivists and auditors. First, we conduct a final audit and closure of risks. We open our risk register one last time. For every open risk, a decision must be made: either it is closed, or it is transferred to the balance of another system. In the end, we prepare a final risk closure report. Second, we ensure compliance with data retention requirements. Laws and standards often require storing certain data and records of decisions taken for several years. Together with lawyers and personal data protection specialists, we verify that the plan for retaining and deleting data complies not only with external requirements but also with internal data management policies. This means controlling end-to-end cascading deletion of data from all systems, to fully satisfy the right to be forgotten and ensure compliance with the approved retention schedule. The ethical aspect here lies in responsible handling of the system's legacy. We must ensure that archived data containing personal information are securely protected, and that the shutdown process is as painless as possible for users. And finally, we initiate a lessons learned process. This is perhaps the most valuable contribution to the company's future. We organize a team meeting to discuss what went well and where we made mistakes. All conclusions are documented. The AI system passport and the risk register are moved to archived status. The passport is supplemented with links to all final documents: the decommissioning plan, the final risk closure report, and the lessons learned document. This entire package is placed in long-term storage, serving as the final audit trail and a source of knowledge. At this point, the lifecycle of our particular AI system comes to an end. So colleagues, before you is a consolidated map of everything we studied in these 2 lessons. This is an integral framework for managing the lifecycle of an AI system, assembled on a single slide. I understand there is a lot of information here, and it is hard to read in a few seconds. The purpose of this slide is not to make you squint at it, but to show the full scope and structure of the process we have gone through together. To let you use this powerful tool in your work, we have prepared this table as a separate high-quality document. You can download it in the learning materials for this lesson. And now I simply want to draw your attention to its logic. From left to right, for each stage, we see how activities lead to documents that form the stage's deliverables, and which roles are responsible. This is your working framework and checklist. Use it when planning projects, auditing current processes, or communicating with the team to make sure you haven't missed anything. This concludes our big journey through the lifecycle of AI systems. We have completed the full circle, from the strategic question why, to the final act of decommissioning. We have seen that each of the 8 stages plays its irreplaceable role. The roadmap we studied is not just a formality or bureaucracy, it is a powerful scaffold based on the principles of governance by design, continuous risk assessment and documentation, enabling us to build AI systems that can be trusted. As I said at the very beginning, these 2 lessons are a guide to our core responsibilities within an AI project. You now have a full understanding of where and what tasks we will need to solve. The rest of our course will be devoted to how to approach the tasks at each of these stages in depth and professionally, from conducting risk assessments to configuring monitoring systems and developing ethical guidelines. Thank you for your attention, and see you in the next lessons.